Okay, so I'm recording this and I'll send it to to everyone, all right? So that hopefully our absent students will be ready. So what I'd like to do is I'd like to go question by question on your actual exam. And we'll do the exam tomorrow. So what would have gotten you ready for the exam would be all those activities, right? We spent, 2 weeks going over population activities? Do we all agree on that? Right? We went over, I think a couple of you didn't get the practice test. Well, one of you didn't get the practice test. I don't know if our absent student has or not. I think there's 2. You need to, before you leave today, we'll make sure you get a copy. They're back there. All the extra copies, everything are back there. So I thought, why don't we go through each of the questions? And of course, I'm not going to read you the questions, but I'm looking at them. And what I'll do is I'll cover it. I'll ask you, do we understand this? We'll go over the highlights of each of the questions. And then by the end of the period, we should have already gone over all the content, and you'll know what content is on the test, so there's no surprises. Let me tell you right now, before we go any further, I'm not giving you an FRQ tomorrow. There's going to be 25 multiple choice questions. So with 25 questions, I think I can give you an FRQ, can I? 25 multiple choice questions. I want you to go through.
So, we didn't do that FRQ, that was in the practice test and someone talked about.
Oh Lord, I don't understand. People coming late. Is it not one of us? I'm in class, you have to come back later. I know I don't have the documents. Come back before the end of school. Does it say, yeah, I'm not sure. It should say, no, this is the package you did. No. Let's not worry about that. I know I have a copy somewhere. If not, I'll print you another copy. Come back at the end of school if you need another copy. All right. Okay then. So that's the plan. You are going. Let me change that up. We will do an FRQ tomorrow. Let me tell you what the FRQ is going to look like. You're going to have to interpret a graph. You're actually going to have to graph some data. You're going to have to, and you'll have to answer 3 questions and answer the questions fairly clearly. So they're going to give you some data in 2 paragraphs. You'll have to read 2 paragraphs. There's going to be, you're going to have to calculate. So let's go down the list of things you're going to have to do. You're going to have to be able to calculate crude birth rate. Like as I said, I want to look at the test. I want you need to be able to do this, and you're going to have to graph it and label. So you're going to have to graph and label data. That you have processed on the FRQ. You're going to have to answer some questions and decide on some answers. All right, that's going to be your FRQ. So it's not like a history FRQ where you have a question and you have to, write out. There's going to be some calculations involved. Bring a calculator. Or I need to clear the memory of any calculator you have. Let me rephrase that. Shoot, I keep forgetting. AP Environmental Science, no calculators. So you're going to have to do the math by hand. Okay. You can't use calculators on a test. So that's for the FRQ. You'll have that tomorrow. Do you all feel like you have the ability to calculate crude birth rates and graph and label data from a couple paragraphs that you'll read and answer some questions about population questions? Huh? Yeah, the numbers are relative. I'm looking at the numbers now. I can do them in my head. I'm not sure what you mean by too big. They certainly are reasonable. They seem reasonable, and I think you're just going to have to do some addition and subtraction. And so I think you can handle that, even if they're big numbers. I think you can add and subtract on paper, right? So, and I'm not being sarcastic. Some people can't. They've been using a calculator so long they forgot. So it's an issue. There are some division stuff as well. You forget how to divide? Okay, so that's something we're gonna have to,
Just let it take calculator.
well, it's just, no calculators, because you're not allowed to use them on the AP exam, right? All right, so let's go, so that's something that's reasonable, hopefully you do well. If you don't, what I'd like you to do today, after I go through the list of things that you have to know, what I'd like you to do is to get the books out and go back over how to calculate crude death rate. What is crude death rate and birth rate? Over 1,000. Some number over 1,000. And crude birth rate is how many people are born per 1,000 people. So if I tell you, well, I'll give you some examples and you can work them out, but we'll also look at the book, and because I know some people haven't read the chapter, but I'm sure that's just not statistically speaking. You go ahead and look at the chapter and make sure you understand what crude birth rate is. Fair? Okay. So that's the FRQ you're going to have tomorrow. Now, let me pause it for a second. All right, so we've been talking about populations. Why is anyone worried about population? And by the way, again, this is our exam review, right? And what have we done to review for the exam? Let's go over what we've done to review for the exam. Number one, in class, you tried to do the exam, right, the practice exam. In class, practice exam. Number two, you had all kinds of activities and practices in class, right? Number three, you took the practice exam home and you went through it with a fine-tooth comb. Now, no one's come to me after school for tutoring. So I'm gonna tell you this, that I'll have a session with you. Huh?
You have the bio kids in here.
I do, but I'm here, I've had plenty of time, plenty of days when we haven't had any, and I'll have all kids take turns. So if you come here, you can do some work in the back until I get through each kid one at a time, and I give you, if I have a lot of kids, maybe you'll get 15, 20 minutes with me. If I'd have very few or none, then you could have as much as an hour with me. So tutoring is always, I'm always here for you. So home practice, and for, as I said, tutoring. So today I'll be here after school. If you have any issues with any of this and you want to have some more one-on-one work, please feel free to come here after school today. Oh, wait. Yeah, that's true. I'll be here till about 4:30 because I have a meeting at 5, so I definitely have to be here till 4:30. All right, so that's exam review. That's what we're doing. So now we've gone over what the FRQ was. The next thing is, my question is, what are we worried about with populations? All right, exactly. Go. We don't want to go over, going over.
Or under, really. But we're not really focused on that.
Carrying capacity. And that's the major idea, right? And what is carrying capacity? What would it do if, and I have to mention, because did mention just a second ago, it is important that you understand that that having too few is problematic. So just remember that we'll come back to that in a minute. So that's an issue. But going over is the biggest problem, because too few just leads to economic outcomes. So this is just economic, which is not small. If you've ever been out of a job, that is not a small thing. If you've ever been poor or out of a job, then you know this is not a small thing. But there are much bigger issues if we go over. What are those big issues, right?
Access to resources.
Right.
Density.
So access to resources is an issue. And what else? What happens when we have overpopulation? What are some of the outcomes? You're going to be asked many questions about what are the outcomes of having too many people in the population. Resources, right? Space, food, etc. What else happens? Sanitation is an issue.
Healthcare.
Exactly. So we're talking about disease, right?
Yeah.
So these are issues, and some examples of, what are some examples of in developing nations that we've seen with healthcare? What have we seen recently in the news? The last 4 or 5, 3, even 4 years. Let's go back since you've been in high school.
Disease.
What kind of diseases have we seen?
Zika,
Ebola,
HIV.
Zika. That's right. Zika, HIV. These are all big issues that the world is dealing with. And in part, and there's one that nobody ever talks about that's also could be the one that hurts us all, is the flu. It's a big deal. All right, so move on. Everybody understands that, right? And so, all right. So the big question but you have to think about, what is an environmentalist? What's the viewpoint of the environmentalist? Now that we talked about overpopulation as a problem, disease and death of humans is important, but if we're considering the environment, we have to think about our speaker coming in, right, and talking about how overpopulation then starts to deplete and impact the environment around us. Does that make sense? In fact, we just had a question this morning because one of our students was going over, I don't like to say names over while we're recording. It's a kind of a rule I have. The FBI suggests this rule not to say names over the internet. So we have a student came in and asked about the environmental laws. Could you say your question now?
I said, what does farm supplements mean in the Food Security Act? What does it mean to deny farm supplements to those who converted wetlands to agriculture?
So one of the laws that everybody should be going over is this Farm Security Act. And in the Farm Security Act, one of the components is withholding supplements, farm supplements. Farm supplements is the question. What are farm supplements? Well, it turns out that one of the big problems, and you remember from history the Dust Bowl, right? One of the big problems with farming is that we quickly take up all the nutrients in the soil. And if you don't have nutrients, nothing really grows in it. If it doesn't grow, there's no roots holding the soil together. And then the wind storms come in and and that's why they called it the Dust Bowl. They blow the soil around, okay? That's a real issue. With farm supplements, one of the many acts and laws that the government has passed is that the government decided to supplement farmers or give paychecks to farmers, in some cases for not to farm. And the reason is that one of the reasons that the Dust Bowl happened and over farming happened is that farmers have to produce a lot to make money. And sometimes what they're producing is not helping the environment, it's not helping the soil, and it depletes our resources long term. So we started saying, okay, well, in some cases we're going to need to pay, because a farmer can't just say, okay, this year I'm not going to be a farmer because I'm not going to make money, I'm going to go work at a factory, and then next year I'll come back and farm, right? A farmer's a farmer, that's what they do. And they have to invest money and careers and lives into this job. So the federal government said, we will supplement farmers by giving them dollars, money, in some cases for not farming. And one of the rules that the federal government enacted in an act is to say, if a farmer fills in a wetland, then we are going to withhold this money, these supplements. They're not getting them. And by the way, we'll talk more about these supplements because we also give them to oil companies, even today. We give them to a lot of different companies, and you'd be surprised, are getting supplements from us, even though they're making a lot of money. From us, because it comes out of our taxes. All right, so withholding farm supplements is a big deal. And why wetlands? Because we're concerned about farmers, which is what we're talking about. Farmers, population getting so big that the farmers then start influencing and impacting our environment. We had a whole lecturer come in and talk to us about what it means to eat meat and what eating meat means to how much farmland, how much of the land has to be converted to farm. That includes wetlands, and wetlands are very important for stabilizing the soil, stabilizing the water quality for the people that drink water, especially well water. And since all people drink water, that's an issue. The next thing you have to know is your difference between K and R strategists. And by the way, you don't have to know that that act. That was just a question. Remember, you have to be studying those laws. I want you to memorize the laws, so when we go through and discuss the laws, we all know what laws we're talking about. K and R strategists. What are they? How are and what does it mean to be a K strategist and R strategist?
So like, it's basically like two ways of looking at a species. Either one species is like dominant and there's a lot of them, or it's like not dominant and there's very few. But the dominant species is easily like killed, and the not dominant one is like better off. It's like dominant.
At first I was going to say I didn't like the use of dominant and not dominant, but I like the way Gina. Oh, I'm sorry. I keep forgetting not to say names.
That's fine.
So
Yeah.
I do. I don't want. I want to keep everything safe, so let's not use names. So when we're talking about K and R strategists, the key here is that we have this slope, and you all know this. Everybody recognizes that shape, right? And we know that K strategists, they're working at carrying capacity. All right, K is carrying capacity. R is the slope equals the slope of the line at exponential growth. All right, and so this is this line here. That's what this R is. And when you're talking about K strategists, you're talking about the strategists that you work at this level, at carrying capacity. All right, so R strategists are working at exponential growth, where K strategists are working at kind of a more flatline growth. So what are we talking about? Well, K strategists, and I'll just versus R strategists. You all should have read about this. Have you read about it?
Yeah.
You've gone over it in the packet in the lab, so okay, good. So K strategists, you have what? What are the characteristics of a K strategist?
They're stable. Like they don't really fluctuate as much.
All right, so good. I like that. Population fluctuates less. All right, that's good. Now, of course, that means our strategist population fluctuates. What does that suggest? Fluctuates.
Increase and or decrease.
That's right. So increase and decrease would suggest what? What does an increase or decrease suggest? When we talk about population, what does increase and decrease suggest? How do you increase a population? Babies reproduce, right? How do you decrease a population? Death.
So in like.
So here you have few births, right? Here you have many births. Is this comfortable? Does this feel useful going over this?
Yeah.
All right. So I really feel. Yeah. Go ahead.
The K, they're like kind of like the bad and bougie. Like they're stable. They have like less births. They live in an environment where they function very like well off. Whereas like R are continuously like hunting and like able to like adapt, more adaptable.
I want to get there. I hear what you're saying, and I want to get there. I want to talk. You're right that K strategists, they tend to be the predators, and the R strategists tend to be, and that's right, they tend to be the prey, right?
They can like do more and like figure it out.
Right, but I worry about doing more, using words like do more, but I hear what you're saying, and I want to try to stay within, because I'm thinking to myself, I want you to use words that if you're asked to do an FRQ on this,
Oh, yeah.
on AP, I want you to use words that are going to get you the right answer. I understand what you're saying, but I want you to be able to use the right words in the right order and not say too much that's outside the box, because then you can get a wrong answer, even though I know you know what you're talking about. Does that make sense?
Yeah.
All right, so few birds, many birds. What's a case strategist then? Well, yeah, that's true, but let's first talk about deaths. What about deaths?
Few deaths.
Few deaths, relatively speaking, everybody's gonna die, but few deaths young, right?
Yeah.
Few deaths, they're young. And what about deaths for the young on our strategist? We have a lot, many young deaths, right? Everybody good with that so far? All right. So our strategists tend to have a lot of babies in a short amount of time. That's another thing. Small or short gestation time. Gestation time. I think it's actually. Yeah, all right. I make mistakes spelling. Deal with it. So smaller, short gestation, right? And case strategies have a long and gestation. What that means is it takes longer for the babies to develop, and they spend more time as children or young versus those that are our strategists.
So would that be
They
a
mature
reference
and
to the, like, elephants, like how the 22-month gestation?
Absolutely perfect. That was exactly what, I wish I could draw the elephant like Christian can, because he can really draw a really great elephant. But, oh, yeah, but Christian is actually a very good artist. You should try to look at some of his work. He does a really quick, fast elephant. I'm very jealous. But think elephant as a really great example of a case strategist. Also, another one that's an interesting case strategist is human, right? Humans and elephants, both, obviously the elephant is a better example for that. Yes?
So for the case strategists, like, because they have so few babies and because they want them to live, they take a lot of time caring for them, and they have a sense of community within their species. Usually,
That's right.
Which is like elephant and humans are great examples.
Yeah, exactly. Yeah, good.
So yeah.
Yeah, absolutely. That's exactly right. What she said is exactly right. So I hope everybody got that. Now, with our strategists, yeah, you're thinking of something like mice.
Yeah, they just produce a whole bunch and they just let them go out and do what they want to do.
Exactly. Or frogs, or whatever, or fish. And what you get is you have a ton of babies, but do they expect these babies to live? No, they don't. And so that's really, so when in fact, you'd be surprised, some people don't know this, but with fish, when they have 10,000 babies, a lot of the fish, as soon as they have the babies, as soon as they actually, not even before they have the babies, as soon as they lay the eggs, they fertilize outside their bodies. So the female lays the eggs in the water, the male swooshes by and lays his sperm, right? And the sperm and the egg combine. Almost immediately, in a lot of species, the parents start to eat them.
Oh wow.
Because so they just start, it's like, wow, what had just happened? Because there's absolutely zero bonding, right? It's like, look, there's food in the water, I'm eating it, right? Because they have so many babies in order to maximize because there are strategies. Their strategy is have a lot of babies. Some of them will survive. They don't all have to survive, just some, right?
Yeah.
So the really interesting strategy that goes on. Same with mice. Mice tend to have this R strategy type of reproduction. So these are reproductive strategies.
Don't those turtles too, the ones that they leave their eggs on the beach and they have to come back?
That's right. Another one's turtles. If you think about those sea turtles, They'll go on the beach, they'll lay maybe, I don't know how many, but a lot of eggs. And you can actually go to California, there's a time in California, I forget what the time is, but when they hatch, the whole beach is alive with little baby turtles all moving towards the ocean. And you'll see actually people in California line the beaches to protect the turtles because they want the turtle population to increase because they're endangered. Actually, I think recently they've bounced back. And they stopped like the seagulls and such from swooping down and eating them. The more of those turtles that get into the ocean, the more the bigger the population in the ocean. So it's interesting. Yeah, they have major. So let's look at something else that's related to this, and that's the survivorship curves, right? If we have time here on the X, and you've seen these, right? And percent surviving, right? Let me do that. So what percent survive into old age? Old is over here, right? You all agree that old is here, and young is here. We're all good with that? All right, so some strategies, some species, what they do is they invest their kids, they're young, a lot of the young survive, and then they end up dying when they get older. That's called type 1. So you need to know what type 1 is. Type 1 survivor, that's elephants, that's humans. Right, so elephants and humans. We're here, we're type 1. That would be a case strategist, right? The case strategist. There's a type 3, and they actually use Roman numeral, where they have a lot of babies. They have 100% of whatever babies. Now here we have few babies. So really this isn't really K or R, but case strategists tend to have this curve. That's why we have few babies, because we invest, like Gina said, oh, dang it. Like we have a student saying, there's a lot of investment in the youth, right? And the youth then stay a long time, and they stay alive as long as we can make them stay alive so that they can eventually have as many babies as they can. But like humans, we generally have a baby every year at max. We don't have babies like 2 or 3 times a year, right? Usually you can only get a baby once a year out of a human. Of course, you can have twins or triplets or what have you, but other than that, we have a birth a year, a birth event a year. Yeah. Oh, thank you. No, it's recording. It's recording, sorry. What, did I mess up?
Yeah, you deleted it.
Huh?
You deleted it.
Deleted what?
The recording, when you start a new page, it deletes.
Oh, no, when I start a new page, it continues. See, the timer's down here. That's what lets me know. Ooh, scared me. All right, so yeah, when we're talking about case strategies, when the type 1 strategies, the babies, the survivorship curve, the type 1, they live a long time, and then most of the deaths happen when people get older, or elephants get older, and that's what happens, right? Now, type 2, you have babies, there's 100% of whatever number of the babies. Notice they're not talking here, this is percent surviving, right? Most of the young in type 3, rather, die real young. But some of them survive a very long time, and ultimately they reach the end of their lifespan. All right. Now here's what's interesting. Here's what's interesting with the type 2. Again, this is type 2. So type 1, the elephants and humans, they live a long time, they die. Notice that the young and the old, that all of us live until we're old. Some salmon are 10, 15 years old when they swim back upstream to lay eggs. But most of the salmon died young. So what you get is most of the young most of the those that were conceived died early, but those that survived lived their full length of their time. Question.
Is that for that one supposed to be type 3? It's on here it says.
Oh, I'm so sorry. You're right. I said type 2. I meant type 3. Thank you for that correction. So that's type 3. Where did she go? I don't know why students insist on leaving when I tell them not to. Yeah. Oh, Lord. Well, I'll just have to deal with that later. All right, so type 1 and then type 3. And I wanted to talk about type 1 and type 3 first because to me they're the clearest examples of what we can relate to K and R, right? If elephants are kind of a type K, right? Then, and humans, then you can see how a type 3 is very, very closely related to the R strategist, right? So if you're going to put the R strategist somewhere, you'd probably want to put him here at this stage. Is that correct? All right, so that's kind of, there are organisms that are in between. They're in between this type 1 and type 2 survivorship. There's some organisms that as time goes on, there's 100% of the babies, and as time goes on, there's a constant loss. Oops, that's a bad drawing. There's a constant loss, right? And that's type 2.
Top one, top latest, and top two.
Right? We all agree? So we have type 1, type 2, and type 3. So type 1, we're dealing with elephants and humans, and type 3, we're dealing with R strategists. But type 2, they're kind of like, yes, they could have a lot of babies at one birth, and sometimes songbirds are a good example. And that's what the I think the book talks about songbirds. But songbirds are a good example. You didn't even think of an ostrich. An ostrich is not a songbird, but only has one big egg at a laying and one a year. Songbirds will mate once a year, but they'll have 6 or 7 young.
Songbirds are like finches and
Think of canaries. Think of the ones that sing. Any bird you hear singing in the summer or spring. So most of the birds that we see outside are songbirds. Not all of them, but a lot of them. They're not birds of prey, which are falcons and eagles and such. They're going to have less. Birds of prey are predators, which is what the other student was saying, that with case strategists, you tend to have less babies, and that you have to think about the trophic levels, right? So if you're going to be higher up on the trophic level, there's going to be less of you. Okay? All right. So anyways, type 3, the songbirds, think about it. You have 6 kids, and over the years, you lose some of them, but you don't use all of them. And so it's not quite as long, and you'll notice that with birds, they will invest a lot of time taking care of them. I'll give you an example of birds that's really a key that actually emulates humans. Do you remember the emperor penguins? The males will spend all winter taking care of that one egg. And they'll take care of that one egg all winter. They'll go without food for months, and they'll rotate from inside the circle to outside the circle, trying to survive winter. The female's out hunting and gathering food, and she then walks miles to bring food back at the end of winter so that the child, the newborn, can survive the long walk to the ocean. So that's an example where you're gonna have some deaths, but it's not going to be like fish where you plant 10,000 young ones and thousands die before them. Okay, so that's K&R strategist. We're all good at that. That's going to be on the test. You need to be able to kind of predict the global human population. All right, so with the global human population, you're gonna have to be able to predict, and you're gonna get some graphs. You're gonna have some graphs that are gonna be on the. You have to be able to, look at something like this. We have year, and you have population, and you have to be able to be careful with the units, right? And you're gonna have some kind of graph that's gonna have some curve on it. All right, something like, whatever. You have to look at it and be very careful of how you read it. And you'll have to predict. I don't think that's going to be hard for you. All right, okay. Here's some more crude. You have to be able to talk about the crude rate of a population again, be able to calculate it. How do you calculate it? To be able to describe it. Let's see here. You have to be able to do what is the doubling? Can you do doubling time? Can you doubling time? Right, so make sure you know how to do that. Seriously, she's not coming back? She can just step outside?
She walked down.
Okay, I don't understand. Okay, that's something anyways. All right, so which of the, okay, so I'm sorry, I almost read the question. No, that's okay. All right, so what are the characteristics of populations?
Large quantities of the single species.
I see what you're saying, yeah. A single species is correct. But so what do I mean by that is when we have exponential growth, what are those, what does that look like? What qualities does a population that is having exponential growth, what does it look like, right? And when it's having logistic growth, that means it's slowing down towards carrying capacity, right?
Mm-hmm.
What does that look like, right? What kinds of the growth rate, what's happening to the growth rate over time, what's happening to, where on the curve is it, right? That kind of stuff, be able to tell that. Yeah.
It's the J curve, right?
Okay, let's go ahead and take a look at that. So if you have a curve in a population, we know that all curves in all populations are going to look something like that.
Yeah.
We know that this is carrying capacity. By the way, you should be able to identify carrying capacity, so that's going to be an important part. Which is right here, right at the top, where the plateau, the limit, right? Those of you that take calculus, the limit. All right, that is your carrying capacity. All right. So then exponential growth is happening here. So the fastest growth, the steepest part of the slope. Fastest growth. That's when the growth is going almost vertical, right? When it starts to turn vertical. When you see the growth slowing down, that's logistic, right? So you go from exponential to logistic growth. So what we have is a slowing down of the curve towards the carrying capacity. Now you're having a slowdown. So there's a slowdown, and the fastest growth is at the exponential. Are we good? So exponential growth is when you have that big increase, where you have something's growing at x to the second, x to the third. Dear, where are you going?
I have to call.
But why'd you
Right
leave?
here, I'm not gonna leave.
But you left. Where'd you go?
What's the bathroom?
But next time you have to sign out. You have to sign out and
Okay,
take
I'm
the
gonna sit right
pass.
here though, okay?
Okay, but you shouldn't be calling in class. This is an issue.
It's a medical emergency.
Oh, well, okay. You can go to the office. I can write you a pass. You can go to the office, dear. You don't have to go use the phone there in
No, I'm
class.
just having to learn. Keep teaching.
Okay, then. Okay. All right. So the graph, which graph best illustrates the population growing at its biotic potential? So what we're talking about is what happens when something is growing. Oh, I just read the question. Well, that's one question you know what's going to happen.
Hey.
See, that's why distractions really bother. I can't with this distraction. So biotic potential. What is that noise? Is that construction again?
That's the
God, I don't know why they have to make so much noise. All right, well, biotic potential, know what it looks like to be in biotic potential. What does it look like what kind of graph are you looking at when you're looking at something going at biotic potential? What is biotic potential? Who remembers what that is?
It's the ability of a species to grow without limitation.
Right, the ability for a species to grow without limitation. So it's the ideal situation. It doesn't exist in nature.
Yeah,
It doesn't exist.
Sufficient food, sufficient space.
Exactly. No disease, nothing negative, everything's positive. So basically the ability to have babies, right? And nobody eats the babies, there's no predators. What's the absolute highest rate this population can grow. What would that look like?
I wanna know, would that be like at carrying capacity then, if it's the.
Well, carrying capacity is what, that's a great question. I literally was gonna go over that. So carrying capacity would not be that biotic potential, would it? Because what's this carrying capacity? What are you doing? That's the limit. That's when you stop growth. This is zero growth, right?
Would bionic potential just be a J curve, but it just keeps going at that?
Is the biotic potential gonna be here, or is it gonna be here?
Right there at the fastest.
Yeah.
Here, so it's at exponential. So when we look at exponential growth, really, if you look at an exponential growth, what you're looking for is this.
And it would just.
That's it. That's what you're looking at. That's exponential growth. If you look at any other growth, this is logistic growth. This is the whole thing here. The whole thing is logistic. But when you're looking at logistic, the fastest part of the logistic curve is exponential. All right, do you see that? Can you see how this line here, looks very much like that line there, right? At that part of that line. Okay. All right, so let's move on. Let's go through some of these other questions here. Let me pause this so I can look. Okay, so know your demographic changes, what's happening at each of the demographic stages, 1, 2, 3, 4, and 5. Know that. You're going to have at least 2 questions on that. Know what happens in the age distribution at various figures, at various stages. All right, so that one's okay. All right. So no. So if you were given a percent, if you were given an initial population and you're given a growth rate, can you calculate how many? Can you calculate using only a pencil and paper and scientific notation? You have to know your scientific notation. Can you calculate the how many people or how many individuals are going to be added? They're going to be big numbers. You think so? Do you want to do a practice problem? Okay, just to make sure. All right, so let's say we have 9 billion people. Let me do it in black. Let's say, fast forward, we have 9 billion. Let's not even say people. Pick something else, anything. Carrots. So, okay, you have 9 billion carrots, and you're at 2% growth, right? Growth every year. In scientific notation, tell me, let me give you another number, because I'm going to give you something that's closer, because it's a little harder, because it's not going to be you're not going to give you usually a whole, like, nice little easy number. So let's say,
4.2 million.
I'm trying to pick a number that, all right, there. So you have this growth, right? All right, what is, if this is the growth rate, how many carrots are you going to have next year? How many carrots are you going to add to the population next year?
100.
Assuming that you have, this is what you're starting with, and this is your growth rate, so that includes death, right? So it's not like you're killing that. So go ahead and do it. Try to do it right now. And the answer is going to have to be times 10 to something. Something times 10 to something. That's what I need you to answer. That's what I need you to format the answer. give you a second to think about it. Okay, so first of all, I guess the first question for you is how are you going to get 9 billion into exponential notation? How do you do that? So I would, what I would do if I were you is I would write 9, comma 1, 2, 3, comma 1, 2, 3, comma 1, 2, 3. That's 9 billion, isn't it? And you all know that? You know your places? There's no issues with that? Okay, seeing no issues. We go ahead and number them. 1, 2, 3, oops, I don't know why I did that. 1, 2, 3, 4, 5, 6, 7, 8, right? And one more, 9. So it's 9 times what? 10 to the 9th. That's all easy, right? Now, what I'm telling you is to do this because if they give you millions, it won't be 9, right? If they give you billions, if they give you thousands, it won't be 9. So count them and make sure you're getting it right. Don't get the problem wrong because, and let me tell you, if you know it's times 10 to the 9th, you almost don't have to do, what if I give you that, what if I give you a bunch of different ones, I say times 10, you know, the answers, here's your answer choice, A, B, C, D, times 10 to times 10 to 2, 4, 6, 9. No matter what this is, right? Which do you know the answer is? It has to be this one. I don't need to do any math. So, do you see why? Oh, McKay, do you see why? He is tired, I know. I'm tired too, I understand. But you get, stand up, wash your face, I get it. So times 10 to the 9th, right? Look at it and tell me, why is it that I don't have to do any math? I'm starting with this. I have this growth rate. Why do I not have to do any math? All right, why wouldn't it be any of the ones that are less? Huh? No, think about the logic here. The logic is simple. They could give you all kinds of crazy numbers. Look at it. I want Omake to answer this. Omake, look at this. I give you, this is your starting population, right? This is your growth rate. Why is it that this is the only reasonable answer? I don't even have to do any math. All I need to know is what factor was it times 10 to what? Why did I not have to do any math?
Even though there's no question, what are we trying to find?
Oh. So we started with 9 billion. We have 1.11% growth rate. What's the population after a year? Now, growth rate is obviously generally always a yearly growth rate. So what's the population over here? Their choices are A, B, C, D. Notice I didn't put any numbers here. I just told you times 10 to what? How is it that I know that this is the answer? Come on. The answer is simple, guys. This is easy. Look at it. The answer is right in front of you. I don't have to do math. That's why when they tell you you don't need a calculator, you really don't. Is there no one's going to answer?
You just said that he was.
Oh, well, he's not answering though. He's confused. Are you confused, Omake? I'll rephrase it again. You're starting with 9 billion people. Your growth rate is this. How do you know that this is the answer without ever calculating how many you added? You know what? How would you get the answer? What would you do to get the answer?
If I had a calculator, I would do 9 billion.
9 billion. You would put 9 billion.
Yeah.
Yeah.
Divided by
Divided by.
0.00.
You would divide by 0.001. Is that what you would do?
I would find what 11.1.11 is in 9 billion as a percent. And find my answer.
Huh.
Very smart.
If you had a calculator, I'm concerned that you're not, are you listening to yourself? I'm not sure what's, say it again, because I'm not understanding, I'm not clear.
If I would do 9 billion divided by 0.00111 and find the answer.
Huh, okay. That would be wrong,
Really?
yeah. What would you, does anybody else know? And I'm sorry, I may have sounded sarcastic there, but I didn't mean to. It's wrong, so be careful, it's not divided by. Yep,
Okay, well, since you just multiplied those.
That's right.
1.11,
we take 9 billion, if I had a calculator, what I would do is I'd do this. And I'd multiply times 0.0111. And I'd get some number, and then I'd add it to 9 billion. Right? Because if I multiplied this times this, that would only tell me what is 1.11%. Does that make sense? 1.11% of this is not, that's just how many I've added. So be careful with that.
Or you can just multiply it by 1.11 and get.
Thank you.
the
Yes.
Actual.
Exactly right. That's the other way you
That's
can.
100%
Yeah, that's
fine.
exactly right. That's
No
exact. Did you hear her? Did you hear her? See, that's exactly right. She's right. I just want to make sure you understand what we're talking about. You multiply these two together, and what you're going to do is you're going to equal some number, right? And that number is how is 0.0111% of 9 billion. This is how much you've added, number added in a year. Do you understand that? You're good with that?
Yeah.
Don't anybody leave now. I know we're close to leaving, but really this is essential. You're going to need it for tomorrow if you're going to be successful. Listen, this is how many you've added in a year. So you have to add it to your original 9 billion. Does that make sense? Now, what this student said here is that she's right. Instead of multiplying times 9 times 0.011, right, you need to take that number added. If you multiply times 1.0111, then you get that 9 billion plus whatever this is. If you multiply times 1.011. You can do it either way, I don't care. But you have to do it that way. Now,
Taking the extra step, basically.
yeah, you're taking an extra step. But hold on. Nobody's answered the answer. Why is it I don't have to do all that math?
Because it has to be bigger than 9 billion.
Thank you. Because it has to be bigger than 9 billion. It can't be smaller, so these others are wrong.
But isn't that assuming that each answer has only one exponent?
Yeah, given this. Why do you think I did this example as I'm looking at the actual test?
Because there's something like this.
Because there's something like this on a test. If they give you a complicated percentage, they're not going to expect you to calculate it all out on a test. Look for other clues that might help you know what the answer is without needing to calculate.
Yes.
Does that make sense?
Yeah.
You might have to calculate it, but there may not be a need to calculate it.
Yes.
Could I just go over the rules again one more time? Please don't leave in the middle of class without letting me know where you're going. And please, no phone calls in class. You can't have it. I don't want to have to refer anyone to the office. Please don't do that. Thank you. Have a good day.